All right. My name is Sam Shannon. The date of today is 7/20/26. And this is a presentation on the combined spectral problem using IR, 13C, and 1H spectrums for this C10H12O compound here. So looking through these, the first one here is our IR spectrum. There's a few points to kind of make here. So when we're looking at this, we have to look at these different peaks to be able to tell us a little bit about the structuring of this C10H12 O molecule here. So this is what we're looking at here. So few things. First of all, we have a very prominent peak up here through the 3000 range. That is going to be an aromatic and alkyl CH stretch. So we typically see these high numbers more on this left side are going to be the CH. So that's very prominent there. So we'll get rid of that. Now going down a little bit more here, we have around the 1700 range, so kind of right in here we have a very prominent peak. That is going to be our aldehyde C double bond here, so that's an aldehyde there. So that confirms that, and the IR spectrums are really good for identifying the different functional groups. So in this one here, we are finding the functional groups. We're just going to put F for that. Now going down the 16 to 15 range, so we kind of have this range right through here. We've got some prominent peaks. These are going to be our aromatic C stretches, so our C double bond stretches, and these are aromatic, so it's going to be part of a ring. So that tells us that this is most likely already going to be a benzene because we have some double bonds there. But we have to keep going just to confirm the rest of the functional groups here. 1450 to 1350, we do see kind of right through here. That is going to be C2 to CH bending. So that is going to be our ethyl group right there. So we know there's an ethyl group attached. And then going one more time down to the 1250 to 1050 range, which is going to be right in here. We've got a lot of points. We definitely know that that's aromatic by how many peaks there are there. That's going to be our aromatic CH bonds. So that further confirms that we have a benzene because we've got some aromatics that are single bonded, and then further down we had some aromatic bonds that were CC double. So that's just going to kind of complete the benzene ring there. That kind of gives us that classic benzene shape with those double bonds. So that essentially confirms those functional groups. Now we need more information to be able to identify the exact structure. So we're going to go down a little further here to the the CNMR. Now this just tells us the different layouts for the carbons. So what this tells us here, around 1850, which is this one right here, we see a single peak, which is going to be our aldehyde from earlier. So that's going to be that. Go down to the next one right around 160, we see that's going to confirm our aromatic C attached to the CHO. We go down a little further through here. We have the 14 to the 120 to 140 range. We've got three different peaks here of carbons, so that's going to further confirm our aromatic carbons there. And then all the way down here, we've got a few other carbons right around 40. That's going to be our benzylic C H2, so that's in the ethyl, and then right down here at the end, this is going to be the end of the CH3. So we've got our CH2 and our CH3 down here, and that just further confirms that ethyl group there. So that essentially tells us we have an aldehyde, we have a benzene ring, and we have an ethyl group. So we already know a lot about the structure, but we do need to just confirm here with the HNMR, which tells us kind of about the bonding here. So right off the bat, we have a 6H that tells us about our ring right through there, so we don't need to look much at that. When we go a little higher, right in here around 3, we have a single. That's going to be our CH2, and then we go up higher, we have the rest of the aspects of the ring. We have our aldehyde up high, just like on the other two charts, and then we have our aromatic H's and our H2 ethyl through there. So that just further kind of confirms the bonding order there. We can tell by those H's that this is going to be that structure that we kind of confirmed on the last step here. Now, going down, we've got all of this filled out based on what was found in those charts, but I did want to touch on this number here, the DU number. So the way to calculate this, there's essentially a formula. So I'm just going to write it here on the side. We take the 2C plus minus H, and then we divide that over 2. Now filling this in with the formula, molecular formula we have over here, this would essentially be 2 times 10 plus 2 minus 12 hydrogens divided by 2. That gets us 10 divided by 2, which gets us our final number of 5, which we put here. So that's how we got that value. Now, just scrolling on down here past the charting to the final product that we came up with. So going down here, we have the exact structure that was shown by the those spectrums there. So we have our ethyl group on the left side here. We know we had a benzene ring because there were some double bonded carbons as well as some single. So that's where we get that from the spectrum. And then we knew we had an aldehyde, so that's where we have our bonds to the carbon here with the double bond to the oxygen to make the aldehyde. And that is our final product.